Hello and welcome. Central to the study of networks is understanding the generally accepted models that describe network functions. These models provide a framework for understanding current networks and for facilitating the development of new technologies to support future communications needs. You will encounter the OSI model and hierarchical networking models as you study networking, but in this video we will examine the TCP/IP model. As we examine the TCP/IP model, we see that it's made up of 4 layers: application, transport, internet, and network access. Each layer has specific responsibilities. The application layer is responsible for encoding data into a form that can be sent over a network and to decode data when it's received from the network. The transport layer supports communication between devices when messages are being sent across the network. The internet layer determines the best path for a message to be sent through a network, and the network access layer controls the hardware and the connections that make up the network. Each layer has specific protocols that facilitate communication. These protocols, which are implemented on both the sending and receiving ends, interact with each other to provide the successful end-to-end delivery of messages. Let's look at how the communication process happens as explained in the TCP/IP model. First, the creation of data at the application layer of the source device. Next, segmentation and encapsulation of data as it passes down the protocol stack of the source device. Then, the generation of the data onto the media at the network access layer of the stack, followed by the transportation of the data through the inner network, which consists of media and intermediary devices such as routers and switches. Finally, the data is received at the network access layer of the destination device, where it is decapsulated, reassembled, and passed up the stack to the application layer. As application data is passed down the protocol stack on its way to be transmitted across the network media, various protocols add layer-specific information. This is commonly known as the encapsulation process. The form that a piece of data takes at any layer is called a protocol data unit, or PDU. During encapsulation, each layer wraps the PDU that it receives from the layer above with its own specific information. At each stage of the process, a PDU has a different name to reflect its new appearance. The PDUs are named according to the protocols of the TCP/IP model. As we look to the right of this graphic, we can see the names of the PDUs. Data is the term for a PDU at the application layer. The segment is a transport layer PDU. The packet occurs at the internetwork layer. Frames at the network access layer. And bits are PDUs when physically transmitting data over the medium. These terms will be important to know because network engineers use them to reference the layers of the network and in troubleshooting. When sending messages on a network, the protocol stack on a host operates from top to bottom. In this web server example, we can use the TCP/IP model to simulate the process of this web server sending a message to the web client. First, the application layer protocol, HTTP, begins the process by sending the data to the transport layer. Here, the application data is broken into TCP segments. Each TCP segment is given a label called a header containing information about which process running on the destination computer should receive the message. The transport layer then sends the segment to the internet layer, where the internet protocol is used. Here, the entire TCP segment is encapsulated within an IP packet, which adds another label called the IP header. The IP header gives the packet traveling directions by adding source and destination host IP addresses. Next, the IP packet is sent to the network access layer, where it is encapsulated within a frame header and trailer. Each frame header contains a source and destination physical address, and the trailer contains error-checking information. The bits are then encoded and placed onto the network media by the network interface card of the server. When receiving a message on the destination side of the transmission, this process is reversed. The data is decapsulated at each layer as it moves up the stack toward the end-user application, ultimately resulting in the application displaying the information, which in this case is a web page. The encapsulation and decapsulation processes are important to know because they form the basis for how all data is sent and received on a network. In this video, we've examined the TCP/IP model and the encapsulation and decapsulation processes. The TCP/IP model is essential for a network administrator to know because it provides a framework for understanding and a vocabulary for discussing how protocols interact, how messages are transmitted, and how networks function.